Now, the relationship here for molar mass is comparing the amount of substance in 1 mole. So let's consider 12 nickels, 2 aluminum cans, and a balloon full of carbon dioxide gas. I would like you to answer A, B, and C with the person next to you with your first thought. Ready, set, go. All right, let's look at our ideas. A, what do you think? Nickels, all right, that's a guess. B, greatest number of atoms? Carbon dioxide. It's got a formula of CO2. That might be true. What would this depend on? Maybe the volume of the substance, for example. Which has the greatest number of moles of atoms? Okay, could be the balloon, could be the nickels, right? Nickel's got more mass, balloon might have a larger amount in the formula. Now, 12 nickels is approximately 1 mole of nickel. 2 empty aluminum cans is approximately 1 mole of aluminum. And a carbon dioxide balloon, if it was this big, this would be approximately 1 mole of a gas. 1 mole of a gas occupies how many liters according to this balloon? 22.4. So if you have a gas, it's proportional to its volume under standard conditions. So how can we convert between mass and moles? So to do this, we are going to use the periodic table. A mole of atoms or molecules of a solid or a liquid is an amount you could usually hold in your hand. And for gases, under standard temperature and pressure, which we will focus on for this part of the course, it always has a volume of 22.4 liters in 1 mole. So to find out the molar mass of a substance, we take their formula, sulfur dioxide. What would be the formula for sulfur dioxide? SO2. So SO2, now to find the molar mass, we just find out how many S's we have, how many O's we have. How many S's in this? 1 S. So what we do is we multiply that by the molar mass of S. 32.07 comes from the periodic table. 32.07, that's the rounded or the average atomic mass. We multiply that by the number of S's in the formula. We do the same for the oxygen. What's the molar mass of oxygen? Approximately what? 16, looking on your green periodic table. So we multiply the 2 times 16, that gives us 32. Then we add these two together, 32 plus 32. 1 mole of SO2 has a mass of 64.07 grams. This is called the molar mass. That's all you have to do. Now, once you have the molar mass, you can convert between moles and grams of a compound. So let's look at an example of this. If you have 120.0 grams of oxygen, gas, O2 gas, what do you have in this problem? Okay, 120 grams. What are you trying to determine? What do you want? Okay, how many moles? So this is the question. I would like you to solve this problem using the molar mass of O2. So how do we get the molar mass of O2, first of all? Periodic table. So we got 2 O's. What's the mass of 1 O? 16. We add that to 16, that equals what? 32. I would like you to use this proportion and this, what you have, to determine how many moles you would have in 120 grams. 408, there's some room to take notes, or you may just write it in your notes. Alright, if we look at this problem, many people like to use proportions. Okay, to do this, so you write down what you have divided by what you want. You got 120 grams. You want to find out how many moles that is equal to. The conversion factor you use in this case is the molar mass. So we calculate that to be 32 grams in 1 mole for O2, for oxygen. Then to solve this, cross multiply. 32 times x equals 1 times 120. Solve for x. Divide both sides by what? By 32. Then we cancel out the units and cancel out anything that is the same. X equals 120 over 32, which is going to be 3.75 moles. So there are 3.75 moles in 120 grams. If you got a different number, you can also think about, does it logically make sense? If 1 mole is 32 grams, I should have more than 1 mole for x. If my answer was like a very small number, less than 1, I did something wrong. So think about it after you do it. Does it make sense? Yes, 3.75 makes sense because I got more than 32 grams. Questions or clarifications on this here? Now, if I've got 3.75 moles, how many particles or molecules would that be equal to? This here is another way. If you don't like proportions, this is called the equation. The equation is up here. You go through the same process. You solve for x. Cancel out the units. And we should get the same answer. 120 divided by 32. X equals 3.75 moles. This is using this equation where K is the molar mass. Now, if we wanted to find out how many molecules are in 120 grams of oxygen gas, we want to find out molecules, we just do 3.75 moles divided by X molecules. So if we want to find out molecules, we just set up a proportion, moles over molecules. Now, what's the relationship we know between the mole and the number of particles? In 1 mole, there's how many particles? 602 sextillion, also written as 6.02 times 10 to the 23rd molecules. Solve for x, how do we do that? Cross multiply. X equals 3.75 times 6.02 times 10 to the 23rd molecules. And when we multiply this out, we get 2.2575 times 10 to the 24th molecules of oxygen gas.
Where's the extra molecule? 24.
The 24, when you take 3.75 times 6.02, you get 22.575. And then when you move it back 1, it gives the power of 10. So it's 2.2575. Now, for practice problems on working with this, in our lab manual on lesson